Hi, welcome back to our Honors Geometry playlist. On this video, we're going to look at our Chapter 4 triangle notes. So this is 4.1 to 4.2. The first thing I would do is I would pause the video and get the definitions down. And once you got your definitions written down, unpause, and we can move on. All right, so now that we got our definitions written down, quick note that isosceles triangles, some textbooks will say that an isosceles triangle has at least two congruent sides, and some will say that it has exactly two congruent sides. So if you have an isosceles triangle, depending on what the definition is, some textbooks will say that an equilateral triangle could also be classified as an isosceles triangle because it also has two congruent sides. Now it has more than two, but it has at least two. Excuse me. So that's one quick note there. Some textbooks will say exactly two, some will say at least two as the isosceles triangle definition. Just something to think about. Now, classifying by its angles, first thing I'm going to look for is, are these all acute? Do I have a right angle? Do I have an obtuse angle? Are they equal? This looks like it is an acute triangle. All three angles are less than 90. But also notice that two of those angles are congruent. And since two of them are congruent, if I have two congruent angles, I should have two congruent sides, which means that this must be isosceles. All right, could you please pause the video, try B and then 1A and 1B for checkpoint 1, and then unpause and check your work. Okay, for B, that is a right triangle, and I have three different numbers. None of my numbers are the same, so that must be a scalene triangle. On 1A, I have one obtuse angle, and all of my angles are different, so that must be a scalene triangle. And for 1B, I have all acute angles, and it is equiangular because all of the angles are equal. And then if it's equiangular, if all the angles are equal, then all the sides must be also equal. So that must be equilateral as well. Okay, so these should be, this Microsoft Word formatting didn't translate well to a PDF. All of those symbols should be triangles. So triangle EDC, triangle ABD, triangle BDC. If I look at triangle ABC, what I notice is that I have, if this is X, I have a side that's X units long. I have a side that's two of those, so 2x units long, and I have a side that I have no idea what that is. It's not marked. So that must be scalene if everything is different. And then classifying by angles, that looks like it's acute. Angle C looks like it's acute, and then angle ABC also looks like, well, actually that one looks like it's a right angle, so that would be a right triangle. So a scalene right triangle. EDC, all of these are marked differently. So these all have different markings, they're all different lengths, but there is a right angle, so that should be scalene right as well. And I would encourage you guys to pause the video, see if you can classify ABD and BDC, and then unpause to check your work. All right, so ABD, here's ABD. That looks like it is equilateral. Which means it must also be equiangular. And you could also classify that as acute. And then BDC, wherever BDC went, there we go, BDC. Looks like this one has two sides that are exactly the same. So I have an isosceles, and that appears to be an obtuse angle at D. So an isosceles obtuse angle. Okay. Example 3, I'm going to give you an equilateral triangle DFG and isosceles triangle. Let's go with KLM. Excuse me. In triangle DFG, I'll give you DF equals 3x minus 11. FG equals 9x minus 47. And DG would equal 7. Isosceles triangle, I'm going to give you that KL and LM are congruent. So I'll give you KL is 54, LM is 8x plus 17, and KM will go with 43. All right, now if you were to pause the video and solve these, you'll find your answers, and then you can unpause and check your work. For the equilateral triangle, it doesn't matter which one you set equal to which, right? These are all 3 equal, so you could pick your favorite 2. It doesn't really matter. I might pick 3x minus 11 equals 7, just to keep the numbers nice and small. So x should be 6. And then here you have to use 8x plus 17 equals 54. So you'd end up with 8x equals 37. Or x would be equal to 4 and 5/8, which is the same as 4.625. All right. Again, I would encourage you to take a look at these. RS is congruent to TS. This is an equilateral triangle. This is one, again, that you can try on your own and then unpause and check your work when you're done. And if this is equilateral, on example 5, it doesn't matter which 2 I set equal to each other. On example 4, I have to say that RS and TS are equal. So the only equation I can write on that one is 9x plus 2 equals 6x plus 8. And you would get 3x equals 6 or x equals 2. So I'd get 20, 20, and 5. Here it's equilateral. It doesn't matter which ones you use. So I'm going to use the ones that are pretty close in size and the ones that have all positive numbers. And here you should get, if you subtract the 3x, you'd get 1x equals 9, or x equals 9. So this would be 37. This should be 37, and 36 plus 1 is 37. Now, why in the world do I get 37 for all three? That should happen because I have an equilateral triangle. For 4.2, we're going to talk more specifically about some of the angles in a triangle. I would go through these definitions, write them down when you've got time. There were some parts, some proofs, some problems in chapters 2 and 3 where you had to draw in an extra line. If you remember, it's been a long time, but we had some problems where we had parallel lines, and I had an angle like this where I wanted x, and maybe I gave you, what was 143 and I don't know, 26. And what we had to do was we had to draw in an extra line. We had to draw in an auxiliary line in order to prove the value for x. So sometimes you have to draw in your own extra lines, not always. An exterior angle is an angle formed by one side of a triangle and the extension of an adjacent side. So an exterior angle, if I have my triangle like this, an exterior angle would be out there. So if I extend the bottom side of that triangle, I get an exterior angle. The next definition, the remote interior angles, I always think of this as like, if you're on a remote desert island, you are nowhere near civilization. If you are a remote interior angle, you are nowhere near your exterior angle. You're not touching the outside angle. So these two would be your remote interior angles because they are not touching, they are not adjacent to the exterior angle. We're not going to do any flow proofs in this course. Some courses will. I don't think it's worth our time in this course, so I'm not going to do it. And a corollary is a theorem or postulate that follows immediately from another proof. So here's an example of our exterior angle theorem. The sum of the measures of a triangle, the angles of a triangle rather, are 180. That's the sum. So if I want to find out why the exterior angle theorem works, I've got 40 degrees plus 70 degrees plus A equals 180. So if I add up these three angles in a triangle, I get 180. That's pretty standard. But what do you notice about angle A and angle C? Sorry, there we go. What's going on? What do you notice about angle A and angle C? I'm gonna do that just so that I can look at my angle pair. Well, angle A and angle C, those are a linear pair. If you put that linear pair together, angle C plus angle A would also equal 180. So why does the exterior angle theorem work? Well, A has to add with these two angles to make 180. A also has to add with those two angles to equal 180. So by substitution, I could say 40 plus 70 plus A equals C plus A. And then I could subtract A from both sides by the subtraction property of equality and say that 40 plus 70 would have to equal C. C would have to be the sum of the remote interior angles. and that is always true. Your exterior angle is always the same as the sum of your remote interior angles. So let's look at some examples. Finding the measure of each angle. I've got 85 and 40, so I can find that's 125. That means that angle 1 must be 55. And if you're feeling confident on this one, I think you could pause the video and find your other two angles as well. And then we can talk through checkpoint 1B together. Okay, so 2 should be 55 because those are vertical, and then you got 110, which means that angle 3 should be 70. And if I check my three angles, that should be a scalene triangle, and this, because you have two of the same measure, should be isosceles. On 1B, it's a similar story. 58 and 65 is 123 degrees. So angle 7 must be 57 degrees. Well, if angle 7 is 57, angle 5 must be 57 degrees. And then I can do some linear pairs. So that has to be 123 degrees. Now let's check that out. 123 degrees. Your two remote interior angles. Let me get rid of some of this extra stuff over here. Your two remote interior angles add up to be the same as angle 6. So you could have found angle 6 pretty quickly there. You could have found it in one step if you remembered your exterior angle theorem. Okay, so I've got 57, 67, that's 124, which means that angle 4 must be 56 degrees. And then the final challenging question is, how do I find angles 8 and 9? Well, what do you notice about those angles? What do those markings mean? It means that those two angles are congruent. So you could take 123 degrees plus, I don't know what 8 is, I can make that x. Well, if 8 is x degrees and 9 and 8 are equal, then 9 should also be x degrees. So I should be able to add those three together to get 180. And x should be, let's see, that's 57, so 28.5 degrees. That's angle 8 and angle 9 should both be 28.5 degrees. And a quick reminder for us that the exterior angle is always equal to the sum of the remote interior angles. Now, this is not, strictly speaking, a theorem that you have to know, one that's definitely going to change your life, but it does show up very, very rarely on maybe an SAT or an ACT question, or on some math department entrance exams at university level. So here's my exterior angle, and I know that it should equal the sum of my remote interior angles. So 50 plus whatever that is should add up to 115. On the next problem, 80 and 60 are remote interior angles to 1. Angles 2 and 3 are remote interior angles to 105. And 40 and angle 4 are remote interior angles to angle 5. So you don't necessarily need the exterior angle theorem to solve those, but maybe you should pause the video, try those, and then unpause to check your work. Okay, so on example A, x should be 115 minus 50 should be 65 degrees. On B, I can add up 80 and 60 to get 140 degrees. And what might be helpful here is to find your supplements. So angle 2 should be 40 degrees. 105, well, these two should add up to, where is it? Angles 2 and 3 should add up to 105. So if I take 105 minus 40, what would I get? Or 40 plus x equals 105. You should get 65. And then you can find that this is 75. That also works because these are a linear pair. So for the same reason, a linear pair, this is 75 degrees. And angle 5 should be the sum of those two. So that should be 115 degrees, which means this must be 65. And then I can check my work by taking 40 plus 65 is 105, plus 75 to get 180. And then I've got some corollaries here, and that'll be it for the notes. So some corollaries, some theorems that follow immediately from other theorems. The acute angles of a right triangle. I've got a right triangle. This is 90, so what's left over out of the 180? The leftover parts must also equal 90. They must be complementary. And there can be at most one right angle or one obtuse angle in a triangle. Because what would happen if I tried to have two right angles and maybe like a 1 degree angle? I get 181, and we know that breaks our rule. You know, I can't have three angles where two of them are 90 that add up to 180. You know, same thing, I can't have like 107 degrees and 123 degrees plus something else to get 180. It just won't work. So I can have at most one right angle or one obtuse angle. Okay. Using the 4.1 theorem, these two angles in my right triangle should be complementary. So 60 plus angle 1 should get me 90, which means that that should be 27 degrees. Okay, now if that's 27 degrees, I've got a right angle, I've got 27 degrees. What is the other part of that 90? That should be 63 as well, because 63 plus 27 makes that 90-degree angle at B. And then I've got angle 2 to find. So if you want to find that on your own, you can always pause the video. But I know that 63 and 2 should add to 90 because there's only 90 left. So that means that should be 27 degrees as well. Okay, please pause the video, try checkpoint 2 on your own, and then unpause to check your work. All right, now I know that I have 38, a given right angle, and 2, so that should be 52 degrees. These two have a right angle that's given to us, so that has to be 38 degrees. .52 is given a right angle and 1, so that has to be 28 degrees. I'm sorry, not 28 degrees, 38 degrees. Goodness. 38 degrees. And I can't make this conclusion yet that those are complementary until I've noticed that this is a right angle, which means that the adjacent linear pair must also be 90. That's 52. Okay, so there's our 4142 notes. Let me know what questions you've got, and I will see you soon.